co-teaching this course with Lotta, Lotta Svantesson. Lotta, would you yourself?
Hello, I'm Lotta Svantesson, and I'm the OpenOffice coordinator and repository manager at DY. In this presentation, I will deal with a smaller part on the publishing your research in open access. So this is my brief way. Let me just say also that I resume the recording, Simone. Okay.
Thank you, Lotta. Also, one other thing, because the two of us are going to be in the session, while one of us is actually presenting, the other one is following the chat in case you have any questions, but we hope to have a discussion towards the end. If there are pressing questions, please raise your hand. You can take the microphone and ask, but otherwise we can definitely have a Q&A session at the end of the presentation itself. Okay, let me start with the core of what we are doing here, with the cautionary practice. So this training is intentionally an introductory overview, meaning that we are not, sorry, just a second, I need to move the, okay. Okay, overview, meaning that we are really touch base on a lot of different aspects and practices in the area of open science, but we're not digging deeper into any of them at this point. We just have 1 hour and a half, so it's not enough, definitely for anything in that sense. But we will provide you with a lot of additional resources that you can actually use in order to dive deeper into each of the topics that we touch base on. This will come as a sort of a handout after the training, and you'll get it in your email. Okay, so a little bit of an agenda for the focus of today. We will start with a little bit of an introduction, very short, on the core values, principles, and practices of open science, generally speaking, and we'll move quickly into some practical approaches for you to take up during your research. And we sort of like created two main sections here. One is about practices that you would want to follow while you are conducting your research. And the second part is about, how you actually communicate and publish your research when you are ready. So I'll start with the first section, and Lotta will take up for the second one. And then we'll have a little bit of a wrap up at the end. Okay, I'm going to start with a question for you. How many of you are already familiar with the general idea of open science? I think that we can, you can raise your hand or take up the microphone if you wish. I just wanted to have a sense of if this term, which is widely used and sometimes abused, or it's becoming a straw man in some way, how much you are familiar with it. Would like to go first, if anyone. Okay, I see people saying, or at least moving your head in this direction. So, okay, so I guess you are in the right spot then. Well, I'm going to start with a brief definition of what open science is, and it's one of the many definitions. It's one of the first one that actually came around in a sort of at least formalized way. You might look at other definitions online, and there are plenty depending on the perspective of who actually takes up the idea. But we can really describe open science as the practice of carrying out scientific research in a completely transparent manner and making the result of that research available to everyone. There's a caveat at the end and a question from the author of this paper, which asks, isn't that just science? And it's a very fair question, because supposedly it looks like exactly what science should be. But as you might see, especially towards the end, that you might find along the way some barriers into applying this general idea, which in itself is, I'm sure that it's, you know, trusted by anyone as the way to conduct science. What we mean by transparent, it means that, you know, scientific claims should be, you know, you should be able to test claims. You should be able to replicate and reproduce research. You should be able to understand which are the data backing up any research claim. And also, looking at the last part, the general idea is that anything that comes out as a research output from a research process, especially if research is actually funded by public money, should be available for everyone. Because that would boost science, it would make a more equitable access to knowledge around the world, and there are a lot of other benefits for you, for the research community and the society as a whole. Now, if you think about open science, you should not think as open science as a goal in itself. In fact, open science is actually, you know, a means towards an end, and the end is to achieve a spectrum of goals that are all related to make science more efficient, reliable, and impactful. And that affects you, and as I said, the research community and society, more visible, accessible, and also inclusive, but also more transparent and robust. You'll see through the presentation that there are several steps you can take in order to sort of like move towards achieving these goals. Open science is actually a process in itself, or at least it can be described as a series of processes that you can, you know, undertake. And this is a quite famous picture. It's called the rainbow of open science. And if you look at the, you know, the rainbow itself, sort of like takes steps into the research workflow, which usually it's actually, you know, depicted as a round, but this for the sake of this picture is actually just a rainbow. But you can start from, you know, searching and exploring ideas, collecting data, analyzing data, writing, publication, outreach, and assessment at the end. We'll focus on the first 4 layers in some way here. And we'll take up some of the aspects that are described here, not all of them. The reason is that there's not enough time, and that some of these are, we try to focus on the most, well, we believe at least the most important ones, especially for you that are possibly at the beginning of your research. But, you know, you can always take a look at this picture because it's very practical. First of all, it not only gives you steps into the process that you can actually, you know, reflect upon, but also on the side, some tools that you might want to try out, for example. Here in particular, we will look at the idea of, you know, pre-registering your research, sharing data, sharing code, and we are looking at the analysis side right now. A little bit on the working with Git and GitHub, both on the code and paper writing, and then more on the publication side and the sharing side, which relates to, as I said, written research output, but also the data underlining your research. Okay, I think I'm finished with a very, very basic introduction of the general idea of open science. And I'd like to go through some practical aspects immediately. In this case, we will start with the idea of pre-registration and pre-analysis plan, following by version control for papers and code, and then research data management practices, according to the FAIR principles, and I'll talk about them later. But this is how we actually think about research, open science in the research workflow. So consider yourself at the beginning of your research process right now. So there are some problems. There are sort of embedded in some of the research practices, the way we do it most of the time. and especially in empirical research science at this point. So there are literatures that are distorted by false positive results. There are data mining and tendentious reporting. So the general idea is that, you know, whenever you do statistical analysis, you just cherry pick some of the results in order to make your claim statistically relevant. And there are, of course, a large number of null findings that are invisible to the research community. When you actually conduct research and you don't get where you would like sort of you're testing your hypothesis and you don't get there, those results are still useful, but nobody actually publishes them because they are not felt worth, or maybe you don't find a venue where that kind of information can be actually shared. And these are clearly issues because they actually in some way impede some aspects of science that are extremely important, which relate to transparent, accessibility, reproducibility of research. So how to address this issue? There are several ways, and these are actually taken, some of the slides you see here are taken from a slide deck that I'll put in our outline, sorry, in the resources we will share with you afterwards on a specific training on pre-analysis plans and pre-registration that it's actually carried out at BITS, the Berkeley Institute for Transparency in Social Science. So how to address this issue? The first one is a full disclosure. Disclosure of conflict of interest, disclosure of how you actually got the data, disclosure on a lot of aspects of your research that would preemptive the situation where you might find yourself if those aspects are actually kept secret. Of course, open data and materials, which would support replication of claim. But also, how can you verify that claim disclosed by authors are actually correct and that the data shared is complete and it's not been, for example, cherry-picked, so that the data set is actually the original one that was collected and not just one that it's been sort of manipulated afterwards. This is how pre-registration and pre-analysis plans come in, and they are here to help because what is a pre-registration? The idea is you, ahead of your actual research, share your research design, your plans, and the approaches that you would like to take. And as a researcher, you post these like your entire research hypothesis, the data used to test them, and the planned research design, the methodology, in a publicly available registry. This is a perspective that it's been around for, I would say, a decade or so, more or less, just in order to avoid those kind of situations where transparency becomes an issue. And also, you'll see later, there are several benefits for you and the research community other than that. Just from a sort of methodological perspective, this mostly applies to confirmatory empirical research, meaning that you, usually when you prepare a plan or pre-register your study, it means that you have a research hypothesis and you're going to collect or generate data to test that hypothesis. But that doesn't mean that, you know, working in this area and working with pre-analysis plans impedes in any way or discourages exploratory research. Exploratory research is when you start collecting the data, you're not sure about any kind of hypothesis yet, but you actually start mining the data to look for patterns, and you actually discover, statistical significant results along the way of your research without necessarily having a clear idea beforehand. It also can apply to observational research. Observational research is when you do not collect data, but you actually, for example, use publicly available data. The problem there is that you might be already familiar with the data before preparing a pre-analysis plan, and that's sometimes is considered biased in experimental research, but there are ways to deal with that as well. We are not covering everything here, so but I'm just giving you sort of inputs that you might look up, especially in the resources that we'll share. So why do pre-registration, other than, of course, the idea of that I already explained? So the first one is to round out the body of evidence by creating a sort of a paper trail of unpublished study in an area. It means that you, through pre-registration, sort of place a timestamp on what you're doing, and also allows other people to understand while you are doing the research that you are doing it. And therefore, the research community becomes aware of the kind of areas of studies that are available or that are not tackled, for example. It reduces the risks of data mining, the cherry picking idea. It's also sometimes called p-hacking for people that are, statistically savvy. The general idea is that, you don't want to sort of like select a specific result from your pool of statistical tests. Also generate correctly sized statistical tests in order to augment the credibility. Make open data and disclosure more effective, because you basically state the boundaries of your research, and therefore people, other researchers, can actually take your claims and take your data and check them against your original research plans. And also encourages scholars to more carefully think about their research design, because we don't want to waste resources and funding on poorly conceived projects. Therefore, this is a sort of a body of sort of benefits in working with a pre-registration or a pre-analysis plan at the very beginning of you conducting research. Now, you might have a question like, does it take time? The answer is yes, of course, because it looks like at least an extra step in your research process. But when you think about if it takes more time, the actual answer is no, because this is just a way of reshaping a little bit, or sort of like switching back some of the thinking that you might do later in the game. So there's always a time in your research process when you try to formalize an hypothesis, a clear hypothesis that you would like to test. And maybe you already started collecting the data. So this is just a way of sort of like putting in order, and maybe in the pre-analysis and pre-registration, you actually have to write them down, put the steps in order so that your research is actually conducting in a more systematic way. Now, if you think about what actually might look like the idea of creating a pre-registration, here I have an example from the American Economics Association, especially for the social science registry that you see below. These are the actual fields that you might want to fill when you do a pre-registration of your study. The ones that are in bold are actually the only ones that are mandatory. So in theory, a pre-registration can be very short, and it's up to you how complete you want to be. The more complete you are, the more a pre-registration is useful, of course. But there's always a balance there, depending on how much time you want to spend, what are the benefits that you envision, and so on. And also where to register, what it means to register. There are online platforms that allows you to go through an actual process online with forms and helpers to get your work done. These are just three examples, three of the famous ones. The first one is the one that I mentioned from the American Economic Association, and it's mostly sort of focused on a certain discipline. And then there are two more general ones, the aspredicted.org and Open Science Framework Registries, where you can actually, again, take all the steps you need in order to conduct a pre-registration for your study. Okay, I'm done with the idea of pre-registration. As I said, all of this is maybe a lot to digest, but we are covering a lot in a small amount of time. I just wonder if you have any pressing question before we switch topic. Okay, Lotta?
No, I just would like to say that if you have a look at these registries, which are sort of repositories, it gives you a very, very practical idea of how it can be performed, because I have a feeling also to myself, it sounds perhaps more complicated than it actually can be. So if you browse around the recent submissions and open up the document attached, I would invite you to do that, to see what
absolutely
in practice it is. And well, then I leave the word to Simone, because I know you had some more thoughts of how to get deeper into this, right?
Yeah, of course. I mean, from this perspective, the general idea is just take a look at examples, and those are all guided processes when you get into this platform. So you're not left alone, and there are several sort of guides on how to do this diligently. Another suggestion is also to talk with, you know, whoever you are working with in your research, being it your advisor, colleagues, or other people, and sort of join forces and sort of like share experiences, because a lot of people are actually taking up this approach. So those are sort of my preliminary suggestions. Should I go on? Okay. Just move this back to small. Okay. I'm switching to the idea of version control, which is another one that you might not be familiar with so at least for the term, but this is a situation I'm sure you found yourself several times. I like you to, you know, take a little bit of time and take a look at the comic here, because it's actually it's fun. It's very famous as well. At least I found myself several times in this situation in the past. Certainly while I work on my dissertation. Anyway, the general idea, which I think is depicted very nicely in this comic, is that you might find yourself in situations where you are working on a paper and you do revisions, and you share the paper with somebody else to get feedback. You get the comments. You have several versions on your hard drive. You get the ones that you get by email. You need to put them in somehow, and you kind of lose track of everything, because it's becoming impossible to understand what's the latest version, or which comments is actually applied, and so on and so on and so on. And in fact, it's quite ridiculous if you think about, you know, technology, to have all these multiple nearly identical version and copies of the same document. Yet we all do it. So don't worry if you feel yourself in that situation. But there are certain tools that allow you to do much better than that. And those tools are those that fall under the category of version control systems. These are technical tools, and I apologize in advance if I go a bit technical here, but I try to stay you know, at the very high level at this point. There are actually, you know, specific training later in the semester about one specific version control system, which is Git. But here, the general idea is that a version control system allows you to keep track of changes, creating different versions of the file without replicating the file according to the file names, but like you would do for example, in the case of the comic. It also allows anybody to decide which changes will be made into the next version. So imagine that you have multiple copies because you received feedback from several people, and you need to generate a new one at the end of the process. These kind of tools allows you to decide which changes go into the next version. And each record of these changes is called, technically speaking, a commit. Basically, you decide what goes in the next version and you commit to that version. Also, these systems keeps useful metadata about all the changes. Metadata is information about the process there. Basically, it allows you to understand when a change was done, who did it, what timestamp is there, if there are several changes, which actually is applied and which is not, and so on and so forth. A history of all the commits for a particular project, because you might, the simple example is that you are working on one file, but it might be that you are not working only on one file, especially if you are writing a paper in, I don't know, LaTeX or other systems, or you are using this kind of, or you are developing code, for example. Therefore, you might have several scripts that allows you to, for example, run a data analysis on your data. So all the commits of a particular project and their metadata make up what is called a repository. And the repository is just a full history of everything you did. And it's actually allows you to do a sort of an unlimited undo. You can actually go back to each of the steps in the process and restart from there if you wish, without losing anything, even those aspects that are actually, down the line. You can always sort of like branch in parallel and so on. Repositories like the one that I'm describing can also be kept in sync across different computers, therefore facilitating collaboration among different people. But you also have to think, and this is the first time I heard about this sentence, I was really struck about it, that your utmost important collaborator is your future self. It's so easy to lose track of what you did in the past. Maybe you're working on a paper and then you have to set it aside because you are pressed by your advisor to do something else. And then you go back. And then you realize that you don't remember exactly where you were, what were the steps that you took, how far you got into your research process. This also helps you, have a trace of what you did. Now, I think the most important, or at least the most used version control system, it's actually distributed version control system in use right now, is Git. And I have the feeling that you already heard at least about Git in the past, and GitHub, which is a sort of a online platform based on Git. So let's make it as a question. Have you heard about Git? Nope. The answer is no. Git is actually a tool that has been around for quite a while now, that allows you to do exactly what I mentioned. It's born as a sort of a command line for people developing software, command line tool for developing software, where you can keep track and collaborate with others in your code development. But after the beginning, it's been applied extensively on a lot of other aspects, including academia. And this is especially true when you, for example, work in a sort of a data science kind of scenario, where if you do statistical analysis and, for example, work with R or Stata, there's a tight integration between those tools and Git, just to allow you to keep track of the changes of both the output of your research and the code that would generate those outputs. In general, Git and GitHub are two sort of a complementary aspect of what you do. You can work with Git locally on your machine. There's nothing else you need. And it's basically a tool to keep track for yourself about your work. But you also want to work with GitHub. GitHub is actually a cloud hosted platform on the web that function much like, if I have to give an example, I don't know, I'm sure you're familiar with Google Drive from Google, or OneDrive from Microsoft. It's actually a hosted repository where you can push your repository online and pull it, for example, from another machine. And everything is kept in check. But it's kept in check not like Google Drive, which does it automatically. It's kept in check according to what you wish. So you can actually check out, that's the idea, or clone a repository in any point in time about your work. So you can start from a specific point on a machine and so on. But your local repo, the one that you actually have on your machine, is actually complete with everything. So you can still work locally without working with GitHub. If I have to think about the basics of Git in terms of actions that you can take, the general perspective is that you can modify files in your directory. You stage those files, whatever they are. Maybe you modified more of them, but you want to stage some of them only as a snapshot for a next version, and then you commit those files to the version, and the version is recorded. And then you come back and you work again, and then you commit another version. And all the tracks, all the history of your changes is actually tracked into the repository. As I said, this is again a very high-level perspective on version control, but I hope that it gives you an idea of how it might help you through your research, because it's extremely easy to lose track of what you're doing. It's extremely easy to lose something if you overwrite it. It's also a very nice perspective, and I think it's actually on the next slide. Let me go check a couple more. Okay, especially for the research process and to make it transparent, have this kind of history available allows for building trust on what you did. Now, as I mentioned, Git in itself was developed as a command line tool, and it's available for all the major operating systems: Windows, Mac, Linux, whatever you're using. And that's the picture you see on your top left. But if you're not familiar with command line, which is perfectly fine, there are several ways of avoiding the command line. There are graphical user interfaces that allows you to deal with all the action for Git in a very easy and user-friendly way. One of which is GitHub Desktop. It's the one you see on your left at the bottom. And then if you are familiar with tools like Stata or R, and you're using them for your data analysis through, for example, Stata and RStudio, which is a graphical interface for R, there are integrations already available. So you just need to, connect Stata and R with Git, and it would allow you to do revision control of whatever you're doing there. Now, when you think about version control systems and reproducible research, you need to think that this perspective is really considered essential in support of making your research reproducible and support open science for the reason I already said. In particular, if you keep an open, well, I didn't mention it, GitHub can have private and open repositories. Therefore, you can actually open up your scripts to a certain number of people or to the entire world, so that people can actually see what you're doing. So you can track changes on your project and allow others to understand your research process and building trust and also build upon it. That's how most open source software development works. So people open it up and others contribute. Also, the idea is to promote collaboration. And when code, data, and interpretation of your paper are actually shared and connected, better science really emerge. You might also want to check, and I'm not sure if it's actually available this year, but certainly it's still available, the edition from last year. There's a seminar from Professor Miriam Golden in SPS. Oops, sorry. I didn't mean to do that. Oops, come on. Which is called Practicum in Reproducible Research Methods, which actually takes anything that I said and much more to the next level. So I really warmly invite you to take a look at the resources available there, the readings and the exercises. Okay, the second part is actually, I think, concludes here. I'll move to the third one of my perspective, and then I'll let Lotta take the microphone. Is there any question right now? Okay, I'll move on. The third aspect you need to consider when you are actually conducting your research is think about how you actually manage your data. Data that you might collect, that you might generate, that you might actually use along your research or through your data analysis or to back up any of your claims. When you think about the general term research data management or RDM, you have to think that the practice that I'm describing covers how you organize, structure, store, and care. It's actually very important for all the information used or generating during a research process. It's a very broad sort of definition here, but the general idea is that you have to think about data or any information related to your research as a sort of a first-class citizen in the scholarly communication landscape. So don't think about it as ancillary or something that it should stay necessarily in your drawer or in your hard drive and nothing more than that, because once you publish, they are dead. Well, they certainly need to stay available in order to build a trust on your publication and claims. But also the general idea is that you need to think of your data as one of the research outputs of your research process, and therefore the endless possibility that are available for the research community in terms of when you actually share the data is an extremely important aspect of how you actually conduct research. Now, we clearly all understand that not all the data can be made openly available on the web. There might be, privacy issues, GDPR issues, issues related to, the safety of human subjects and so on. But, and therefore the general perspective is that data should be as open as possible, but also as close as necessary. But because there are techniques to anonymize the data and so on, you always have to think about, when you collect the data or generate data for your research, you need to keep in mind the general idea that, at the end of your research process, or even before, if you wish, you might want to share the data and put them available for other people to use or for your future self to use again. So what are we talking about when you say RDM or research data management? You need to plan how your data will be looked after. And that's usually done through a data management plan. It's in some way similar to the pre-analysis plan we were discussing before, but this is actually related to how you actually collect, store, and manage your data throughout the research life cycle, how you actually make sure that your data is properly described. That, just to give an example, imagine that your data set is handed over to somebody outside of your discipline or outside of your department or lab or research community. Those people, those other researchers should be able to use the data in the most effective and proper way without any input from you. So data should be in some way self-described, and that actually is done through, naming all the variables, allowing people to understand the parameters that you use when you collected the data, and so on, and also adding additional data like when the data were collected, what is the scope of the population. There are several guides that you actually can read in order to understand what are the specifics of a data management plan. But that's another document that allows you to sort of like guide your research in the most effective way. And data management plan can be revised throughout the research. So they're not static documents, but it gives you an idea of how you might want to prepare your data up until the long term. So therefore, even after your project concludes. Now, the general principles that, at least in the most recent year, applies when you think about research data management are called the FAIR principle. And FAIR stands for findable, accessible, interoperable, and reusable. So at minimum, data should be findable. At least a trace on the web, it might be just a record that the data exists, should be available somewhere. It might be a repository, it might be a catalog somewhere, it might be anything that allows people to discover that the data exists. If you move to the next step, data should be accessible. And by accessibility in this context, it means that you need to provide information to people on how to access the data. It doesn't mean that the data should be open. It means that you need to provide information to people in case they would like to access the data. That includes, for example, a persistent identifier telling people where the data are, or the condition for access. If the data are actually closed, what are the potential steps to take in order to get access to them, and so on. The next part is that data should be interoperable. And that goes back to what I was telling you when I was talking about the data management plan. You should describe the data in a way that people and machine possibly can understand your variables. So if people have to integrate and combine multiple data sets, that becomes possible. And finally, data should be reusable, meaning that data that are available on the web, especially, should be licensed with a proper license that allow people to fully reuse them. I don't know if you're familiar with the idea of Creative Commons, but that's the kind of license you might want to look at. Creative Commons is a way to explicitly declare which rights a user has in terms of reusing your data. There are several ones, but the two ones that are typically applied to data are data in the public domain, or people can use your data, but they need to give attribution to you. So whenever they are using the data, they need to cite you as the author of the data set. Lotta, I see a raised hand.
In April this year, we had a special session, which was also registered on Creative Commons. So more dedicated to publications, but still it's a very interesting session held by an EY law alumni, Arghiri Panesi. So if we can maybe share that link as well after, together with the presentation, if it's of interest. It's on YouTube, so it's easy to find it as well.
Thank you, Lotta. At the library, we really provide support in what I just described. What you see here is the cover of the most recent research data guide from the UI library in its 9th edition from 2021. But you can always be in touch with us in terms of preparing your data management plan, how to apply research data management practice throughout your research life cycle, how to think about data preservation and sharing, for example, in Cadmus, our research repository at the UI, and also on the data requirements for EU-funded projects. You can follow the link and you'll find a lot of information related to that. I don't know if we have time, but you might want to go through these couple of slides on your own because they are pretty dense. But it's a story. You have a traditional story where you are sort of, you read through how things have been done traditionally. And the second version, which is a sort of a revised approach, tells you a slightly different story, where a lot of the things that we discussed so far are actually applied. And if you compare the two of them, the traditional story and the revised one, you might understand even better what are the benefits for you and for the research community, for society in general, when it comes to applying those practices in open science. And I think, yeah, I'll stop here so that I give the microphone to Lotta. Well, thank you for the time being. Lotta, it's your, I'll stop sharing for now.
Okay, thank you, Simone, for now. So I will share my screen. I will go for, okay, share screen. I will try to share the whole computer because I might go online, okay? So we'll see. Screen, that should be, no? Okay. Can you already see that?
Yep.
Okay. So while Simone has been talking about the process before the actual publishing of your research output, I'm going to briefly touch about the publishing part and open access publishing. So it's really an overview. A little bit in general about open access publishing and a touch point on our library's agreements with publishers that offers you something in matters as an author. So open access is the free and immediate online access to the research results and also the right to use and reuse those as you need. And that is a very basic idea because you make research literature and outputs available online without price barriers and without most permission barriers. So you have basically three groups or ways or roads to publish open access. The gold way, the green open access, and the diamond access, which is the most noble and rarest, unfortunately. So a gold, let me go back to the view. I see there is a message, maybe.
It's me, Lotta. I'll take care of the chat.
Okay, okay, fine. Okay, good, great. So the first way is, of course, offering for everyone the ability to read for free. But usually you have, as an author, you have to pay for it, either you or your affiliation, or through a funder like ERC or Horizon Europe funding or something. And these fees are usually called, they are called the article processing charges. And in jargon, you will always read APCs. So sometimes these can also be waived through, so that you don't have to pay them through an agreement. And you will see very briefly that we have 3 big deals at DY that offers you this possibility. But otherwise, usually if you go for gold open access with any kind of journal publisher, you will have to pay something from, if you're very lucky, it's 1,000 euro. And if you are not so lucky, it can be near 4,000 for 1 little article, but as we have seen, there have been many versions. You have been working on it, and then you have to pay for it. So it's a big debate if this is a good deal or not. The second option, which actually, according to EUI open access policy, is strongly encouraged, is the green open access, where you as an author can actually go for a journal article publishing, or also a book chapter, and then later on upload it in your institutional archive or repository. Here it is CADVOS, the name of the EY research repository, but you also have subject-oriented research repositories, SSRN in social sciences, REPEC for economists. SSRN, you may know, is basically bought by Elsevier related the company since some years, so it's a commercially linked repository and has cost for people usually, and in any case you have to register. And the diamond access is very rare, but it offers the free to read and free to publish. I would like to go ahead. Let me see if I can. Okay, so some advantages of open access, you will recognize many aspects that Simone has mentioned already, I think, but it creates immediate visibility and dissemination. It accelerates the discoverability, and it offers also greater transparency in the whole research process. It also increases the possibility for you to be cited and be able to claim your work, because if you make it open out there, it's yours by default. It's visible, and you can actually claim it instead of sitting on it somewhere. And of course, it's a public enrichment, and you being if you need to be compliant with the funders' requirements, usually open access is the answer, either green or gold usually. And it can offer you bigger opportunities for collaboration as well, because if your research output is there available and citable and discoverable, of course, it offers also possibilities of networking and collaboration. And last but not least, it offers a potential greater impact. I will then, if you have some questions, you drop them in the chat, or you raise your hand, please. This is a rough image of our EY library read and publish agreements, because this is usually what we are talking about when we talk about transformative agreements. Most of those are read and publish agreements. So read, you know that the library subscribes to great collections of journal packages and serials, but this is not only a subscription to collections in that way, it's also paid for by your institution so that you can publish for free. So that's why it's called read and publish. You also can see publish and read and many different names, but this is what it is basically. And they all have different, quite complex ways of payments and handling this. So it offers quite some work. But for you, let's say, as once your institution has them, you should benefit from them. And this is my message to you. So we are basically talking about journal articles, not about books. There are some other possibilities, but we will not go into them now. If you're interested, you are welcome to contact us, and we will go into that, which is more complex. So the agreements touches only about journal titles. So for you, APCs that can be waived. The agreements that we have are with Cambridge University Press, Springer, and Wiley. a very small publisher called Cogitatio, offering in the social sciences 4 open access journals, where you can also publish open access for free. And ECPR has a very, very low APC for EOI members, around, I think it's 49 pounds. I can go here soon. I'm looking at the time. Sorry, yeah, it should be fine. For one open access journal, instead of more than 1,000. So it's, but that's also through an institutional membership of the EY. Elsevier, there is quite a bad agreement, always through the Italian consortium CRUI. It offers you 10–15% discount on an APC, but if you are going to publish in an Elsevier journal, better to use it than not. So it is there. We are talking about more than 3,700 journal titles. So I'm sure that there can be some of these that can be suitable for your research output to be published in. And as I say, yes, more than 2,000 euro for each article you would save. I would show you the page that you can refer to, that we keep continuously up to date with new initiatives whenever there is an update. Can you see this? Yep, good. So this is the page. It's part of the presentation as a link. So it's, by the way, here to the left, you have our section of the web. We are inside the library, and it's under publishing and open science. And this is the page that will deal with all the library agreements. I'm scrolling down, you can read the introduction. Cambridge University Press, it specifies the coverage, the time, the duration, Springer, how many journals, the time, etc. Wiley, and the bad Elsevier discount. Currently it's 15%, and it will only get worse because next year it will be 10%. So if you can avoid to publish with Elsevier, you could decide not to do it. But, you know, Cogitatio, here are the 4 titles of journals. So it's media and communication, politics and governance, social inclusion, urban planning, and the ECPR open access journal is political research exchange. It's a journal that open access only, and it was created quite recently in 2019. Maybe the first issue was also out only in 2020. It's an important network. So I will go back to the presentation. Who can benefit from our agreements? It's valid for all EY members, at least if they are acting as the corresponding author. Some of the agreements allow also EY alumni, Wiley for surely, for sure, if the article is based on research that is carried out here at the EY. And they are so generous, actually, that we approve this as an institution. It can be important to remember this if your article comes out, if you're leaving the institute. So how do you know which journals are included in all these 3,700 titles? So if you look at point A, if you know about the title in a journal that you really want to publish, or if you have already submitted it and you have had your article accepted, then you can check who is the publisher if you don't know that, and you use the tool Sherpa Romeo. I might have this. I will show you what it looks like. I have a title. I will type the title in the journal title here, and I will know a little bit more about this. I will know immediately ISSNs. I will know who is the publisher. So I know it's Cambridge University Press. So then I know it is possible that this title is included. And I can also have a look at the publisher policy concerning open access. And probably it will be possible also to use green open access. And if I look at the accepted version, you will see that it is possible without any embargo in the accepted version. And while if I open the published version, there will be a fee associated to this. I will not stay on to this, but have a look at this tool because it's useful also in other circumstances. That's one way that you can go about if you know the title. Otherwise, you can also go to point B and go to the agreements, browse their lists, open them because I update them continuously. You will find them through our page that I showed you before. You can open them, you can sort and browse by topic and search a bit. You'll have to download the file probably in order to do those things. So I invite you to check the EY agreements page. If there are things that are not clear, just contact us, okay? So basically that's what I had to say. So I just want to highlight 2 forthcoming sessions on open access. In October, we have the EY Open Access Roundtable in the framework of the Open Access Week. So that will be touching this year's theme. It matters how we open knowledge, building structural equity. And there you will be able, if you register, you will see speeches by publishers, academics, librarians, journal editors, and staff from open scholarship in libraries from different parts of Europe, I would say, yes, and followed, of course, by a discussion. If you are interested to know more about the transformative agreements and a little bit slower and more in depth, I would invite you in the same week on the Wednesday to come to our special session devoted to transformative agreements. So there we will touch a little bit more about the details and how to use them. And this is my last slide to remind you of ORCID. When it comes to publishing open access, it's very useful for you to have the ORCID identifier. It is a persistent, digital, academic author identifier that you yourself own and control from the beginning, and it will follow you through the whole academic career. You can connect it to various institutional affiliations. And it's very important in this, especially when we are at an international institution and performing research, it will distinguish you from every other researcher in the sense also if you have the same name as someone, or if you have a complicated name, or if you have a need to transliterate your name, longer version, shorter version. So you have all these versions of your name connected to one unique identifier, and it also helps to claim your work, and you can connect it, and you should connect it actually to your affiliation now. EY is a member, and this helps you also to fill the ORCID profile that you will have as a CV, especially the work section, because we would then push your publications from Cadmus, which is the EY repository, to your ORCID profile, the work section. I can show last thing, the connect page. I see Simona has your hand raised. Go.
Yeah, just a final thing, because it's also most of the time now a requirement from publishers for you to have an author in order to publish with them. So that also becomes a more, mandatory aspect of what you do. It's definitely required when you actually participate, for example, in EU-funded projects, to have an ORCID as a researcher.
Absolutely, thank you for that. Absolutely true. Yeah. Yes, grants. I should have said that. Yes. So go for that, I would say. And this is my part of the presentation, so I will stop the screen sharing unless there are questions. Okay, I'm trying to stop the sharing. I'm just trying to open up there. Okay.
Okay, I'll have a couple of slides to sort of wrap up the session, and then hopefully there's a little bit of time for questions. So let me share my screen again. Can you see my screen? So this is a little bit about what we learned today, or at least what we touched on today. So the idea of study pre-registration, because it allows for better transparency and reproducibility of your research, when it's also associated with data sharing and open access to publication. How version control can support reproducibility, collaboration, and an open approach to research process. And also we'd like to add, a better relationship with your future self. Research data management, which in terms of practices ensures that your data are properly curated and prepared for sharing if possible. And also open access to publication, which ensures that your research claims and everything you do in your career is as impactful as possible, while also supporting a more equitable access to discovery. I just want to stress that the opportunities there are for you in order to make your work more transparent, visible, citable. There are several studies that actually show how open access publications are much more cited than the ones that are behind barriers. We never really, we only touch base on the idea, and you might not know because you are in an institution in which the library provides subscriptions to a lot of journals, but most of the journals, scientific journals, are actually behind pay barriers, so their access is not free. It's also for beneficial and an opportunity for research community in order to foster knowledge discovery, reduce barriers, and also increase, again, reproducibility and therefore trust on research, but also for the society at large in order to boost innovation and economic growth, save public money because you build on the shoulders of other researchers, and contribute to making a better world. And that's kind of the end goal, I think, here. You might also find challenges along your way, or why, in some ways, open science is not just science yet. There are several cultural, technical, and sometimes legal barriers. But I would say that nowadays, the cultural ones are still the most important one. And I have examples here of sort of sentences and questions that I heard throughout my career that you might hear yourself, or you might find yourself saying sometimes, this is how I've always done it, or how I was taught to do it. Why should I change? I do not have time for this. What do I get out of it? I do not know how to do it. but I'm not going to tell you. So because I'm a researcher and I know what I'm doing. I already have all the tools I need within my own community. Why should I adopt a different one? I give away my copyright. I cannot do it. What if? There are a lot of what ifs that you might find yourself asking. But I think that, I hope that at least this small session gave you a little bit of a bread for thoughts whenever or if you have encountered these kind of questions or statements in your past. And the general idea is also that the times are really changing rapidly. So what we have described here, it's actually a trend. And it's a trend because of many reasons, because people are becoming more aware, but also on the other hand, the sort of the stick side, it's because more and more public funders are actually mandating open access and open science practices in order to, provide grants for research. So you find yourself in a position where if you adopt these practices and you understand, sort of like make your own as a way of doing research, you'll find yourself in a better position in your future. And I think that's it in terms of the presentation. This is our team. And of course, if you have questions, we're here to help. You'll find also our contacts. I don't know if...
More information about library services can be found on our website, and don't forget to follow our blog and social media channels to stay up to date with the latest news.